Hello and welcome as we consider yet another multiple choice question for IB chemistry. Consider the following two standard electrode potentials at 298 Kelvin. And here you have a reaction for tin, and here you have the standard electrode potential for iron. Both of these, of course, are showing gain of electrons, reduction potentials. In fact, everything in the table of standard electrode potentials is, in fact, a reduction potential. But when you put two entities together in a reaction or in a voltaic cell, then one species needs to be oxidized and the other one needs to be reduced. But here, the question is, what is the equation and the cell potential for the spontaneous reaction that occurs in this cell? Now, I've put spontaneous here in capital letters because it's one of the key terms in this question. For a spontaneous process to happen, which is one that has a negative Gibbs free energy, you have to have this N Fe, and of course there's a negative sign in front here. So this negative sign is built into this equation, multiplied by the Faraday's constant, multiplied by the cell potential, which of course must be positive, so that you would be able to get a negative Gibbs free energy and a spontaneous process. So that's to immediately tell you that you can eliminate this as a possible choice. A is not going to be the answer because it has a negative value for the cell potential, which would immediately tell you that it won't be a spontaneous reaction. We then need to look at which of these three is the correct answer. And we need to bear in mind that when we work with cell potentials, we don't multiply by the number of moles. So the numbers that we use are going to stay as given here, regardless of whether the answer has 2 in front of the iron. With that in mind, we have to look at which species is going to be oxidized and which is going to be reduced, because both of these are reduction potentials. But seeing that the standard electrode potential for iron is much more positive than that for tin, it means when both of them are put together in a reaction or in a voltaic cell, that this process would happen with respect to iron. But this would not happen with tin, because in this reaction, something must be oxidized and something must be reduced. But here in the table of standard electrode potentials, both are written as though they are reduced. So we have to imagine that this reaction prevails as the reduction process. And then this has to happen in the reverse direction, because something has to be oxidized, something has to be reduced. But if this is going to be oxidized, then everything has to be looked at in this direction. And of course, that's why we have this reversible sign here. But when everything is looked at as happening in this direction, this sign changes. And then all you do now to find the cell potential, there's no need to worry about right-hand electrode, left-hand electrode, anode and cathode and all of that procedure. All you need to do, reverse this because it's oxidized. This becomes positive. And then positive 0.14 plus 0.77 gives an answer of positive 0.91. So we're looking for a positive 0.91. And we happen to have two of those. But of course, we're looking for a positive 0.91 where iron is going to be the thing that is reduced. And iron here in B is reduced. But you need to have two irons, of course, because when tin is oxidized, it releases 2 electrons. So to get everything to balance, you have to put a 2 in front of the iron. But bear in mind, there's no need to multiply this by 2, because this distractor is here to pick that up. If you believe that you must multiply by 2, then you would do that and you would be confident that the answer is D, but it's not, because you don't need to multiply by the number of moles when you're working with standard electrode potentials or cell potentials. So the answer to this question is B.